Now we're going to move into chapter 2. And chapter 2 has 9 sections. We're going to cover 8 of those sections, maybe get to 9, but we're going to start out with section 2.1. And section 2.1 is simplifying expressions. And we already kind of touched on this a little bit in chapter 1. But in this one, we're just basically going to kind of cover it a little bit more thoroughly. So the first thing that we're going to cover is when we simplify. We've kind of talked about this before, but basically what you're doing is you're combining all like terms or similar terms. So they're either like terms or they can be called similar. And what that means is when we combine these, so basically here's an example. If I had 5x and I wanted to add that to 3x, well, because that these x's or these variables are exactly the same, then really it's rewritten to look just like this. 5 plus 3 and the x just remains the same. Same thing if you were counting pencils or pens. So with that in mind, 5 plus 3 is just going to give me 8x. Now, the opposite of that, if I had 5x and I wanted to add that to 3y, because these two variables are not the same, they're very similar looking and they're both letters, but they're not the same variable. If you simplify this, it's exactly the same. There's nothing to combine for those. You cannot add them or subtract them. Now, you can multiply anything, but we're just covering right now just adding and subtracting. So, if I was to add up x plus x plus x, and remember, all these x's are 1x, so I'm just going to put a 1 in front of them. This is the same thing as 1 plus 1 plus 1, and then of course our x. So if I add all of those up, that's just going to give me a 3x. Now I can do this with subtraction as well. So let's say I had 6y, subtract 2y. The only thing that we're going to focus on, because these are like items, and I can combine them, so that's just going to be 6 minus 2. The y just goes on the outside. 6 minus 2 is 4. So my final answer is going to be 4y. Now, if I am multiplying, and remember I can multiply anything, but let's say I want to use the same one that we have at the top here. So if this is 5x, remember I do my multiplication to look like a star so it's not confused with the regular variable, 5x times 3x. Now because we are multiplying these, we are actually doing this. 5 times 3, and then we're multiplying x times x. And we're just doing these separately. So 5 times 3 is going to give me 15. X times x is the same thing as x to the first power. And when I'm multiplying variables, whatever power they are, I just add those powers together. So this is the same thing as x. And then my exponents would just be 1 plus 1. Well, 1 plus 1 is going to give me 2, so my final answer is going to look like this, and that's a 2. But that's kind of moving ahead. We're just going to kind of focus on our subtraction and our addition for right now, and then we're going to move on. So when we say simplify, and any of the questions that you have, and this can be test questions or anything in your next math class to include the homework, anytime it says simplify, you're just going to be able to add or subtract like items. Remember, we can multiply anything, and that's an example there, but this is really what we're focusing on. Now, another example of that is going to be if I had 5x plus 2y minus 3x plus 4y minus 3. So the first thing we want to establish is how many different terms we have. I have an x and I have an x. We're going to say that's a y. So then I have y, so generally this is just the way I denote them, just so I can kind of keep them a little bit separate. And then generally for my numbers, I just circle those. And if I look, I have 1, 2, 3 variables. And that's probably the most variables that we're going to have for this particular class. So anyway, I'm going to rewrite these just so they're side by side. You don't have to do that. It'll just help you kind of keep them a little bit more in line. So this is just going to be 5x minus 3x plus 2y plus 4y minus 3. Now you don't have to do that. I just think it helps helps you, and it's a little bit easier when you combine them together. So 5 minus 3 is just going to give me 2, and the x comes down. 4 plus 2 is going to give me a 6, and the y just comes down. And minus 3 is my only number, which is also known as a constant. And this is going to be your final answer when you combine those, or basically simplify them. Now the second part of what we're doing, and that one was simplified, but the second part, and you're going to see this one a lot, and not just in this class, but in your next one, is when we evaluate. And the key when you evaluate is basically you're substituting the variable with a number. So there are basically the two that we're going to do in here are going to be a one variable and a two variable evaluation. So for the first one, I'm just going to start out with something simple like 4x minus 3. Now, if I was simplifying this, these two are unlike items and they're not similar, so that's as far as I can simplify them. But when I evaluate them, the key is the evaluation is going to tell you that you're going to come down, or you're not going to come down, but you're going to have a single number as your answer. Not a single digit number, but just a single number, which means you're going to remove the variables. So this x is going to disappear. Now, in order for that to happen, you have to know what that variable is. So this will always accompany that. For an example, this one will say that x is equal to 3. So basically, I'm just substituting this x in here, and this becomes 4 times 3 minus 3. And I just keep working this out following PEMDAS, because we're always going to follow PEMDAS. 4 times 3 is 12. 12 minus 3. Once again, 12 minus 3 is just going to give me 9. And this is going to be our single answer, or a single number that we're trying to come up with. Now, I can change this to something else that looks similar to this. 2x plus 3 minus 3x. Let's just do this one for an example. You can combine these, or you can simplify this, but really because we already know that the variables are going to disappear because we're saying that x is equal to 3, and we're going to use that for this one example as well. So this just becomes 2 times 3 plus 3 minus 3 times 3. And once again, once you remove all the variables, you're left with numbers. So then the numbers are going to just all be combined, and you're going to be left with that single number answer. So if I continue to work this out, 2 times 3 is 6, plus 3 minus 3 times 3, which is just going to give me 9. Now, I generally work left to right, so 6 plus 3 is going to give me 9. 9 minus 9 is going to actually give me a 0 for this particular answer. Now, if I just use any other one for an example, this will be 4x plus 3. So for this one, I'm just going to change this a little bit. I'm going to say for this one, x is equal to 2. Now, I can either distribute these, which means 4 times x and then 4 times 3. But because it's in parentheses, it's easier just to substitute the number in, because then you're just working with straight numbers and you don't have to worry about variables. So this would be 4 times 2 plus 3. And then following PEMDAS, I work out whatever's in the parentheses. 2 plus 3 is going to give me 5. And 4 times 5 is just going to give you 20. And it's as simple as that for single variables. Now, the other way of evaluating, and you can have numerous different variables, but there are also, when you have two variables, the most common ones that we use are x's and y's, but they don't always have to be that. If you think about our perimeter formula, it's 2 length times 2 width. So they're L's and W's, but generally we'll use x's and y's. So for an example of this one will be, let's just say 5x minus 3 plus 4y. So remember, when we evaluate, we're going to come out to a single number. That's still going to happen no matter if we have 2 variables or 3 variables. And the evaluate kind of clues you in that you're going to do that. So in order to remove these, I need to know what the x is, and I need to know what the y is. For this particular one, I'm going to say x is equal to 2, and I'm just going to say that y is equal to 3. So those have to be established first. Once again, I'm just substituting those in. This becomes 5 times 2. The x is equal to 2, so the 2 is just substituted. The negative 3 just comes down, and then the 4y, the y, once again, y is equal to 3, and that just becomes 4 times 3. At that point, we've removed all the variables, and we're going to come up to a single answer. 5 times 2 is 10, minus 3, plus 4 times 3, which is 12. And I'm just going to work left to right. 10 minus 3 is 7. 7 plus 12 is going to give me 19. So it doesn't matter what the variables are. I'm going to use these exact same variables for a different one. And let's just say x squared plus 4x minus 5y. I'm not sure what this is going to come out to, but we're just going to plug in the numbers. It doesn't matter what the numbers change to. The process is always going to be the same, and that's really what we're trying to do is get the process down. So this is just going to be 2 squared plus 4 times 2 minus 5 times 3. And once again, I've just substituted the x for the 2, substituted the y for the 3, and those are just listed here. 2 squared, that's the same thing as 2 times 2, plus 4 times 2 is going to give me 8, minus 5 times 3, which is 15. Continue to work these out. 2 times 2 is 4, plus 8 minus 15. 4 plus 8 is 12. 12 minus 15. Once again, if there's not a number or a sign in front of it, it's implied to be positive. These two don't match, so I'm going to do my two-step process for adding and subtracting. My signs do not match, therefore I subtract. 15 minus 12 is 3. 15 is bigger, it's a negative, so my final answer is going to be negative 3. And that's the process for simplifying.